Hello everybody. This is just a quick video for you on circles vocabulary. You'll notice that this one is a little bit long, like it's a lot of pages, but that's mostly because I wanted to leave you a lot of space for drawing. I also included all of the definitions for you already, because the thing about a lot of this circle stuff is you don't necessarily have to be able to recite the definition of a radius, for example, or a secant, or a tangent, or an arc by name, right? You don't really have to memorize the definition. What's more important is that you are able to recognize what those things look like in an image, right? Or if you are told in a problem to draw, or that there is a tangent, right? Then you have to be able to know the properties of that in order to put together something to help you solve the problem. All right. So I'm just going to be doing a little bit of drawing and labeling here, and I'm going to go through these terms for you. Okay. So these are the most important terms, really all of the terms that deal with circles that you need to know. Okay. So the very first, obviously, is what a circle is. Okay. Which is the set of points equidistant from a given point called the center. Okay. So that is our very mathematical definition, right? But all it means is that no matter where you are, right, on this circle, right, whether you're at this point, this point, this point, way down here, right, it doesn't matter that each of those points is the same distance away from the center, right? Just like if you think about a clock, right, that the hands on a clock don't change their length, right, as they move around the circle. Okay, so that's our very mathematical definition of a circle. Okay. Some of these terms that you're going to see at the beginning, you probably, I'm assuming, have heard a lot of these terms and know what they are, but I just want to give you a quick refresh on a lot of them, okay? So a radius, the mathematical definition is a segment with endpoints at the center and on the circle, okay? So that means radius just goes from the center all the way out. So if this is A and this is B, right? Segment AB, like that, is a radius, right? It goes from the center out to the edge, okay? And the important thing to know, right, is that all radii, right? I could draw another one here, maybe A to point C. I could draw another one here, right? A to point D, that all of those radii are the same length. Always, 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 right? And that goes back to our definition of an actual circle, okay? Center, pretty self-explanatory. It's literally this point in the middle, okay? So it's this point here, okay? But one thing that's important to note is that all circles are named with their center point, okay? So if this center is called A, then this circle would be circle A, right? And typically we write that with a little circle, and then we put the letter A next to it, okay? Or whatever the center point is here, okay? All right, so next, getting into the actual segments in a circle, which is what this whole section is about. I'm going to tell you a little bit about some angles when we get a little bit further down here, but this section, for the most part, is about segments in circles, okay? So first, a chord. A chord is any segment where both endpoints are on the circle. So that is an example of a chord. I'll draw another one for you in a different color. That is an example of a chord. Okay, so it's just any segment that's completely encompassed within the circle, and the two endpoints are directly on the circle. Okay. A tangent. Okay, a tangent is a line that touches a circle in exactly one location. Okay, so this right here is a tangent, okay, because you can see that it touches that circle at only one spot right there, okay? So a tangent is always going to be entirely outside the circle. It's almost like it just kind of like hits the circle and then keeps going on its merry way, okay? A secant intersects a circle in 2 points, okay? So it's almost like a chord that extends beyond the circle. So this is a secant, okay? And really, it should have arrows on either end. Usually they do. Okay, so notice that it intersects the circle in two locations. Okay. All right, a diameter is a very special type of chord, okay? So as you recall from up here, a chord is just any line segment that touches the circle in two places, right? And those two places are the endpoints. Okay, a diameter does that, obviously, right? Because it starts at one end of the circle and goes all the way to the other end. Okay, but the important thing about a diameter is that a diameter must pass through the center of the circle. Okay, so it's a special chord that has an extra property, right? And that property is that that diameter must pass through the center of the circle, okay? Now, there's a couple formulas on here, which I'm hoping that you know, but as you'll notice, in every diameter, there are two radii, right? One here and one here. Okay, so every diameter is made up of two radii, right? So if they tell you the length of the diameter, right, then you can cut that in half and it'll give you the length of the radius. Okay? If they tell you the length of the radius, you can just double it in order to find the length of the diameter, which is what these formulas are right here. Okay? All right. The last page and a half or so here on this is all about the arcs of a circle, which is what happens on the circumference of a circle, okay? Rather than segments maybe that may show up inside, okay? So an arc, okay, is just some portion of the circumference defined by 2 points. So let's say I put the point W right here, and I put the point Z right here, okay? The arc is this shortest possible distance between W and Z, okay? The way that we would notate that is with the two endpoint letters of the arc, and then you put a big arc over the top of it. Okay, so that's how you name those, right? So an arc is just the general term for some part, some portion of the circumference or the outside of the circle, okay? There are two different types of arcs, okay? A minor arc and a major arc, okay? A minor arc, so let's use some different points here. So let's go, I don't know, G and H. Okay, so a minor arc is the shortest distance between 2 points on the circumference of a circle, right? And it always must be less than 180 degrees. Okay, so for example, if I went around the circle the other way, right? If I did my arc like this, right? That's not a minor arc because that arc that you see on the bottom takes up more than, it's larger than a semicircle, right? It takes up more than half of the circumference of the circle, okay? Right? So when we name minor arcs, very similar to what I showed you all up here, we name them with two letters. Okay, so this would be arc GH, right? And then you put a little arc over the top, okay? Subsequently, a major arc, so I'm going to try to draw these in basically the same spot. So G, H, and then I'm going to put a J down here. Okay. A major arc is an arc that measures more than 180 degrees. Okay, so that wouldn't be going from G to H over the top of this circle, but it would be going from G to H at the bottom of this circle and passing through point J. Okay, so the way that you can tell that you're dealing with a major arc is it'll be named with 3 letters following the direction of the arc, right? So this goes from G to J to H. So this would be G, J, H, very similar to the way that you name angles with 3 points, right? And we still have an arc right, over the top so that you know that you're talking about an arc. Okay. All right. A sector. Okay. Think of a sector like a slice of pizza. Okay. So again, I have here G and H. Right. A sector. I got to draw from my center here. Okay. So a sector is just some portion of the area, essentially, of a circle. Right? So this that I'm kind of shading in blue here is a sector of this circle, right? So the very fanciful definition is a region bounded by two radii, right? Uh, and what's called the intercepted arc, okay? So whenever you draw two radii out from the center of a circle, right? And you look at the arc that's between them, which I have outlined in purple right here. Okay, that is called the intercepted arc. Okay, think of it like the crust of a slice of pizza. Okay. All right. And we have a couple of angles that we're talking about here. So central versus inscribed. Okay. So a central angle is exactly what it sounds like. It is an angle in the center. So here I have G and H again. Okay. The central angle is an angle in the center of the circle. Okay, so the vertex of that angle has to be at the center, right, with two sides of the angle that are radii. Okay, so it's this angle right here. Okay, that is a central angle. Okay, think of it like, again, going back to the pizza metaphor, right? Think of it as the tip of a slice of pizza. Okay, now an inscribed angle is a little bit different. Okay, an inscribed angle. So I'm going to change my letters up here. Let's go with J and K, for example. Okay, now an inscribed angle still has an intercepted arc, okay, but the vertex of an inscribed angle is always on the actual circumference of the circle, okay? So I don't know if you all have ever seen those videos where people like to cut foods wrong. I've seen some where people try to cut like pies and pizzas or cakes like this, where they don't go, in lovely slices like to the center here. They make something that looks more like an inscribed angle, okay? So the vertex of an inscribed angle must be on the circle, okay? And then it's made up of two chords, right? So central angles are made up of two radii, right? You have, I obviously did not give this circle a name. I think I called it circle A up at the top here, right? Yeah, I did. So we'll just go with naming it circle A, right? Okay, so this angle GAH is made up of two radii. This angle, I'll call this point L. This angle JLK is made up of two chords, right? Okay, so a circumscribed angle is essentially an angle that happens outside of the circle. So for central angles, we've had our center, our vertex at the center of the circle. For inscribed, your vertex was on the circumference of the circle. For a circumscribed angle, your vertex will be outside the circle, and the two the two rays that make up the angle will be tangents, right? So notice that both of these rays, and I really should, again, have arrows on either end, only touch the circle in one spot. So my circumscribed angle is here, all right? Okay, and then my very last thing here is concentric circles. So concentric just means circles that have the same center. So hold on. I'm trying to get this so that it's right on that center right there. Okay, so think of it almost like a bullseye. Right? A bullseye always has is made up of these rings, right? And they all come from this same central location right here, right? So think of it, like I said, like a dartboard or the Target logo, or you can even think of them as like ripples, right? Going out and emanating from the same spot. Okay, so those are your definitions. Okay, a lot of them, like I said, I'm hoping you had seen before now. Okay, what I would focus on this week is these. So these segments in circles, chords, tangents, secants, diameters, radii, all that fun stuff. Okay, we'll get more into the angles and the arcs in the next section. Okay, so really quickly, I'm going to label this lovely circle that I have right here. Okay, so obviously my circle is just the whole thing, right? A radius is here. Okay, obviously there are other radii, but this segment here is only a radius. Okay, a chord, there are a couple chords here, but this one here is specifically a chord, like you couldn't name it any other thing. Okay, a diameter would be this here, right? Because it's a special type of chord that cuts through the middle of the circle. Okay, and then I have two left. So with the secant must intersect in two places. So that's this one at the top. Okay, and then my tangent is this one at the bottom, right? Because a tangent can only touch the circle in one location. All right, y'all, so that is it for this video. I will see you in the next one where we talk about properties of all of these segments, especially tangents and chords and secants. All right, so I'll see y'all in the next one. Bye, everybody.